All right, you guys have a homework assignment that you're currently working on. So let's review what we did last class because this is the type of stuff that is on that assignment. So we're looking at quadratic equations and solving quadratic equations in this unit, which we've talked about before. We've solved symbolically using the SADMET steps, going through our order of operations for solving. But now let's look at some graphs and tables for solving. And again, this is a review from last class. It's on your homework as well. So if you have this equation for the height of the rocket, and this should look familiar because we used this table last time in the investigation. We look at the equation for this. If we put in, remember this is x and this is y. So time is our independent variable in seconds, which is represented by x, and height in feet of the rocket is y. So if we put a number in for x, and then multiply this out, so for instance, put 0 in for x here, put 0 in for x here, we will get a resulting y value of 84 feet. If we put a quarter of a second, 25 hundredths of a second, 0.25 in for x here and here, and multiply it out, add them together, we get a y value of 99. So if we are given this equation, notice this is the same thing as what you see here, but we've replace the y value here with 139. So let's look over at our table and say, okay, well, where is the y value? Where is the height? Right here, because remember, this is the height. Where is the height? 139 feet. Well, as a rocket goes up, it hits 139 feet on the way up, and then it also hits 139 feet on the way down. So at a quarter of a second, or sorry, 1.25 seconds, 1.25 seconds, it reaches a height of 139 feet and then reaches its maximum height, and then on its way back down, it crosses 139 feet again at 2.75 seconds. So there are two solutions for this equation, and those two solutions would be x equals 1.25 seconds and x equals 2.75 seconds. You'll remember most of the time with quadratic equations we do end up with two solutions, and in this case it's 1.25 seconds and 2.75 seconds. So hopefully you got those. Let's move on to the second warm-up problem. Similar idea here. Again, you're given this time an equation and we're trying to solve it, but this time we're solving it using a graph instead of using a table. All right, so this takes a little bit more detailed analysis. You have to look at it a little bit more closely. Let's focus on this first one. So here is the equation. Here is the graph of that equation. Notice what we've done here is -3 has gone in place of the y value. So let's think about where -3 is on the y-axis. All right, here's 0, -1, -2, -3. Okay, so there's -3 on the y-axis. What we're really asking then is, when does this graph hit a y value of -3? Well, y values of -3 go all the way across this graph. Here's a y value of -3, that'd be 1 -3. Here's a y value of -3, that would be 2 -3. 3 -3, 4 -3, 5 -3. Same thing on the negative side, -1 -3, -2 -3, -3 -3. So pretty much everywhere along this line, right here, is a y value of -3. So what we're asking is, when does this graph actually reach a y value of -3? Well, if you look, it hits that -3 line twice. It hits it right here at 0, -3, so right at the y-axis, and it hits it here again at 2, -3. So the solutions for this would be, what are the x values when the y value reaches -3? Well, one of the solutions was x equals 0, because when x is 0, it has a y value of -3 on the graph. And then our other solution is x equals 2, because that's the other time that the y value hits -3 on our graph. When x is 2, y is -3. So our two solutions for this one are x equals 0 and x equals 2. All right. So let's look at the second equation because you had two equations to solve here. It's the same graph, only this time instead of looking at when does it hit -3, we're looking at when does it hit -4. So we will use the same idea here. When does the y value reach -4? Well, -1 on the y-axis, -2, -3, here's -4. So there's 0, -4, 1, -4, 2, -4, 3, -4, 4, -4. The other direction would be -1, -4. So here's all the -4s on our graph. So right there, that would be when y is -4. So once again, we have to ask ourselves the question, well, when does the graph actually reach? When does our parabola actually reach a value of -4? If you look closely here, notice that it just hits -4 this one time. It just touches right at its vertex, right there, at the point 1, -4. So unlike the first problem where we had two solutions, this one actually only has one solution because it only hits -4 one time before it goes back up again. It never gets below -4 either. So in this case, we only have one solution. When x is equal to +1, the y value is -4. So that's only one solution. So if I had this right here, if it said solve -6 equals x squared minus 2x minus 3, does the graph ever reach a y value of -6? No, it doesn't. So if that were the problem, there would be no solution. So no solutions down here. It has one solution right at the vertex, and then everything above that will have two solutions like we saw in our first example there. Next problem. This is related to or preview of what you're doing in the investigation today. And so let's just take this rectangle and hopefully remember a little bit of our geometry, but our geometry kind of combines with our quadratic algebra unit here. So we're going to look at a length of 10 inches. So we're going to say this is 10 inches long, and we're going to say the width is 5 inches. All right, so what is the area? If you recall from your previous work in some geometry here, the area on the inside here, so the space that that rectangle takes up is found by multiplying length times width. Sometimes we refer to it as base and height, or length times width. So 10 times 5 is equal to 50. And the correct unit on that would be called square inches, which can be abbreviated inches with a little exponent of 2 next to it. But that means that this space fills up, 50 squares would fill up this space here that are each 1 inch by 1 inch squares. Okay, so that would be the area. Remember, the word perimeter means the distance around the rim. Okay, so the distance as we go around the shape would be our perimeter. So that is a distance. It's not an area, it's a distance. Well, if we know this is 10, we know the other side is also 10 inches. And if we know the left side is 5 inches, then this is 5 inches as well. So the equation for a perimeter is 2 lengths plus 2 widths, or you can just add them all up. 10 plus 5 plus 10 plus 5. So 10 plus 5 plus 10 plus 5 is a grand total of 30 inches. Just 30 inches, not 30 square inches, because perimeter is just the distance around. The last of your warm-up problem says if the perimeter of this rectangle is 36 feet, find the area. Okay, so the distance around here, we said, is 36 feet. We're also given one side length over here that is 8 feet. Think of that maybe as the width or the height. Well, if this is 8 feet, we know the opposite side is 8 feet as well. We don't know what the top and bottom are, but we can figure those out because we know they're exactly the same as each other. So if we take our total perimeter of 36 and subtract out 8 and subtract out another 8, in other words, subtract out 16, that leaves us with 20 remaining feet for the other two sides. And since we know both of those other two sides are equal to each other, if we just divide that in half, divide it by 2, we get 10 feet for the remaining sides. So we get 10 feet and 10 feet here. Let's just check that to make sure it still works, because we know the perimeter is 36 feet. So 10 plus 8 plus 10 plus 8. Well, 10 plus 8 is 18, and then another 18 gives us 36. So that works. Okay, so that means that our area, because don't forget we're supposed to find the area. Area is length times width. So 10 times 8 would be 80 square feet. So that's going to be our area. One other thing I want you to notice with this is that we know the perimeter is 36 feet. And if we know one length is 8 feet, well, or think of this as the width. A length and a width, one length and one width have to be half of 36, right? Because 2 lengths plus 2 widths was the total of 36. So one length and one width here have to be half of 36. So if we know this is 8, we automatically know this is 10 feet. Because 10 plus 8 is 18, and 18 is half of 36. So the other one would be 10, and then this is 8. So we know that that would be a total of 36 feet for the perimeter. And again, length times width would be our area of 80 square feet. So in the investigation in a few minutes, be thinking about that. If you know one length and you know the perimeter, well, one length and one width will be half the perimeter, just like 2 lengths and 2 widths would be the entire perimeter. And then we can multiply those together to get the total area, which again was 80 square feet.